second thing is we're going to also talk about appendicular innervation, and I'm going to teach you a systematic way of looking at it, right? And so basically today is the day where it's going to be like the most normal lecture where I'm just going to tell you a ton of stuff, okay? Now the good thing is, this is not on your exam tomorrow, so you don't have to digest all of this overnight. You actually have until the end of next week to work on this and digest, and I'm still writing some questions to help you with this, stuff like leading questions, right? But what we're doing is we're actually talking about just muscles in general, right? And not the physiology, the names of the actual muscles, you know, the kind of basic locations. And so how do you know what the innervation is? So there's a system. There's basically a system. For axial musculature, it's super straightforward, right? So the big thing that we're worrying about for axial musculature is we're worrying about this. This is the kind of division that we need to pay attention to for axial musculature. Is basically epaxial versus hypaxial. Because what we understand is epaxial regions, right, and epaxial musculature. And we're focusing on motor innervation. We're focusing on, you know, the motor nerve that actually goes to the muscle. Yes, it has sensory coming back from the muscle, but we're focusing on the motor, right? Because wherever the motor is, there's going to be a sensory neuron accompanying it, right? So if you're going to the epaxial region, innervation is basically just going to be dorsal rami. Okay, so when we're doing this innervation, all we're really focusing on is the fact that for epaxial, you're going to use dorsal rami, which then go into that muscle. If we're talking about the hypaxial region, including the limbs, then all you're going to do is focus on ventral rami. So a ventral ramus is going to come down, and it's going to go all the way down to the most ventral aspect of the hypaxial region. Bless you. Now, what's going to be different, and we will talk about it again, like later today in this lecture, is the appendicular stuff. We're also going to include our dorsal and our ventral divisions. Okay? But this is it. This is as simple as it gets, because I am not going to ask you to memorize for the hypaxial stuff things like ilioinguinal, iliohypogastric. Right? I'm not going to ask you to remember those names. All you have to know is if it's an epaxial muscle, what is its innervation? Dorsal rami of segmental nerves, or you can just say of spinal nerves. Okay? So if we're dealing with the thoracic region, and you've got the back muscles, right? So the erector spinae muscles, longissimus, iliocostalis, those things in the epaxial region, essentially, wherever they are, they're just receiving dorsal rami from either lumbar nerves or thoracic nerves. If you're all the way up here, then it's receiving from the cervical nerve. That's it. If you're dealing with your intercostal muscles, where are they going to get their innervation from? Ventral rami of your thoracic nerves. That's it. And you don't even actually have to give me like a particular segment. You just have to know if it's hypaxial, it's going to receive from ventral rami. That's it. That's as straightforward as I think it can get. Okay? So for the innervation for axial, very, very straightforward. Okay? Now, when we're actually talking about muscles themselves, one of the things that's very useful is if you understand how muscles are named. Okay? So, if we're talking about the naming conventions for musculature, then one of the things that you're going to want to pay attention to is the appearance of the muscle. Because that's often what we're doing, because that's all anatomy really is descriptive. All you're doing is describing what you see. Right? So it would be like if I took this chair over here, anatomy of this chair, right? It's not how does it work, how does it function. All I'm doing is describing what I'm seeing. So I say, blue chair with black armrests and metal legs. That's anatomy. That's all anatomy is. So for this, all we're doing is describing what we're seeing. So the muscle, you can describe muscles in many different ways. You can talk about the shape of the muscle. So this is where you start seeing things like quadratus. Quadratus means that it has this shape. That's it. It means it's a quadrangular shape. That's a quadratus muscle right there. Looks just like that. Okay? Now, we can also talk about the number of heads, because that's also a descriptive thing. Like if you saw somebody walking down the street and they had two heads, how would you describe that person to somebody else? Would you be like, oh, it was a fat person? What would you say? It was a guy with two heads. That's what you would say. You would focus on that aspect of the description. So same thing right here. Quadriceps, 4 heads. This muscle back here, which one is this? Triceps, how many heads? 3 heads. What about in front? 2 heads, biceps, right? That's all you're doing is describing the muscle, right? Now, there's another thing that you can do, is you can also talk about the location, okay? So location-wise, when we're talking about absolute, absolute means that it is not in relation to something else. It's not going to be above something else or below something else. Absolute means that's essentially its precise exact location. So what did you tell me this muscle was right here? Biceps. What's the full name? Biceps brachii, because where is this biceps? In the brachium. Where's there another biceps? No, brachialis is a totally separate muscle. Where's another biceps muscle? Where? Biceps femoris, exactly. Because there's another biceps back here as part of your hamstrings. So you are giving the absolute position. It's the biceps of the brachium or it's the biceps of the femur, okay? That's an absolute one. Now, on your shoulder right here, on your scapula, you have 2 muscles, right? You have an infraspinatus and you have a supraspinatus. Those are relative positions because they are in relation to an external landmark, in relation to the scapular spine. So one muscle is above it, so it's supraspinatus. One is below it, so it's infraspinatus. The other way we do relative positions, which muscles am I using right now? This is going to segue into the next thing too. Which muscles am I using right now? What am I doing? What am I doing right here? Flexing my digits. Flexing my digits. Right? So which muscles do that? Digital flexors. But more than one digital flexor. There is a superficial digital flexor and there is a deep digital flexor. Notice that they are named for their position relative to each other. One's more superficial, one is more deep. Okay? Now that brings up the kind of segue. I'm going to skip over origin and insertion for a second, and we're also going to talk about the function. Because what did we say? What muscles am I using? Flexors. And what are they flexing? The digits. It's telling you exactly what the muscle does. Okay? Now, the last one, origin and insertion, these ones seem like they're really weird, right? But the truth is, these are probably the most straightforward names that you can think of. Okay? Because all you're going to do is you're going to name the muscle by telling what its origin is and then telling what its insertion is. Okay? So if you're talking about, we have like these strap muscles which are going up and down here in the hypaxial region, and it'll come up in just a little bit. One of the muscles is called geniohyoideus, right? So if I split this up like that, and I put it in 2 parts, genio is its origin. Genio is referring to your chin, okay? The genu right here is of your chin. And then the hyoid, where's the hyoid bone? Here, right? Kind of buried underneath your tongue right there. So this is a strap muscle that goes from your chin down to your hyoid and actually lifts your hyoid up a little bit. And the opposite effect is it can actually draw your chin down and open your mouth just a little bit, okay? And then here's the other general rule. It's not perfect, but the general rule is whenever you're talking about muscles, they're going to end with that sound, us. They're going to end with an us sound. So it's either going to end with a us or an is. Those are the 2 most common endings for muscles, right? So the muscles right here, the 6-pack muscles, what are they called? Proper name? Rectus abdominis, right? Rectus abdominis. Make sense? Biceps femoris. Does that make sense? Right? So that's the kind of rule, right, of naming the muscles. And then the other thing is you basically take into account shape, right, the location, the function, those kinds of things, right? So this is how you know that you're dealing with muscles, is the ending. And then also, if you're trying to name a muscle, all you got to do is describe what you're seeing, okay? Now, for the epaxial stuff, the epaxial, It's relatively straightforward, relatively, right? But this is going to bring up something, is there are patterns, right? And the pattern that for whatever reason we end up seeing over and over and over and over again, okay? We just see it for whatever reason. I don't have an explanation. Groups of three. We tend to see things in groups of three, okay? It's not everywhere, but it's often enough that you can kind of start to rely on it, okay? And so what we're going to do is we're going to talk about the epaxial muscles back here, but they come in three layers. So there's a superficial layer, there's a middle layer, and there's a deep layer. That's a grouping of three: superficial, middle, and deep. Okay? Now, this belongs to the overall kind of block of musculature that's referred to as the erector spinae, because they are holding your spine erect. So they pull, right, from the pelvis, and then they pull higher up on the more superior regions, and they pull your spine into the erect position. And then this actually brings up a really good point. I had mentioned origin and insertion, but one of the things that you have to pay attention to is what's the difference between an origin and an insertion, okay? Origin is the more stable portion, okay? And then the insertion is the part that's more mobile. So usually you see the action of the muscle at the insertion, okay? So the example, and I do this, like I do it all the time, this is always the way I do it, is if I hold my arm out like this, right? And I'm going to use this muscle right here, right? Biceps brachii and brachialis and a couple other muscles. When I contract this muscle, it should go like this, right? This is the more mobile portion. This is where it's coming from. So here's the origin, here's the insertion. This is not what's supposed to happen. Where this is stable and this part moves, okay? Origin is always more stable. So if we're talking about erector spinae, this is going to look weird, right? When I use my erector spinae, this is more stable, so I do this, like that, and it pulls here. These are the insertions up here and up here and up here. It's not like this, right? And then what happens is, right? I mean, I'm doing that consciously, right? But do you see you get the point? The more stable portion is the origin, okay? That's the easiest way to understand origin versus insertion, okay? So the idea is, this is originating from down here. Iliocostalis is part of that superficial layer of your epaxial. In particular, it's part of the erector spinae. And it's originating from down here off of the ilium and also off of the sacrum. That's why it's called iliocostalis, because that's where it comes from. That's its origin. And then it's inserting up here onto the ribs, like that. So it inserts onto the ribs one by one by one. So costa, those are the ribs. That's why it's iliocostalis. If we're talking about, right, still in the superficial layer, another muscle of the erector spinae group. By the way, how many muscles belong to erector spinae grouping? Three. There it is. Pattern of three, a grouping of three. Now, we went from a little bit more lateral muscle. Now we're moving to a little bit more medial muscle. Okay. Now again, this one's still going to be originating coming off of the ilium, coming off of the sacrum, and it's going to be moving in the superior direction, and it's inserting onto the transverse processes. Now this one is named for its appearance. This is the longest muscle in your entire body. And the kind of like modifier, isthmus. Isthmus means that it's very much whatever you're calling it, right? So it's long, that's why it's longest. And then if it's really long, then it's longissimus. That's why it's called longissimus. Longest muscle in your entire body, okay? Now, one thing you should notice about this is, and I'm going to exaggerate this, don't look at those black arrows, right? Because I don't actually need you to differentiate and say longissimus lumborum, longissimus thoracis. I don't need you to do that. But I want you to notice something, is these muscles, okay? Both the iliocostalis and the longissimus, I'm going to exaggerate what they're doing. They are going in this direction. So they're actually, as they're going from their origin up in the superior direction to their insertion, they're moving laterally. Both of those muscles are doing that. It's very easy to identify these muscles because they move in the lateral direction. That's not the same thing when you look at the next, the next muscle for your erector spinae group, this is the last one. It's the most medial of your erector spinae group, still in the superficial layer. This one, you can call it the spinalis series semispinalis, right? But the thing is, it's actually best if you just talk about its origin to its insertion. So it's originating off of transverse processes, and it's inserting onto spinous processes. Therefore, it's called transversospinalis. If it's originating off of transverse processes, is it originating more medial or more lateral? Originating off of transverse processes, going to spinous processes. It's originating more laterally. So, it's actually going, I know this drawing is not perfect. I'll show you something else in just a second. So, for the longissimus and iliocostalis, they were going this way. I'm exaggerating it. For the transversospinalis system, they're going this way. Because they're going from transverse processes to spinous processes. Very distinct, because you have a complete change of direction all of a sudden. Okay? Now, for every single one of these, they belong to the erector spinae grouping of musculature, which constitutes, right, basically the superficial layer of your epaxial musculature. Now, we're also going to have, right, some deeper muscles, right, which we're going to kind of peel these away and then start to see them. But before we peel them away, I want you to see, right, you can see iliocostalis. Here's iliocostalis coming up, inserts on the rib, onto the rib, onto the rib, onto the rib. That's iliocostalis. Can you see how it's moving sort of laterally? When we talk about longissimus, longissimus is actually coming up like this. Can you see it's also kind of lateral? And then I'm going to do a different color. Transversospinalis, we're actually starting to see some of it coming up right here, like that, moving in that direction. So it's going in the opposite direction. Now, we're going to peel some of this stuff away in order to look at the deeper musculature. And the deeper musculature belongs to the intermediate layer. Multifidus. Multifidus just means that it has multiple origins. That's all that it means. So we don't even name, every single origin. We know that it's coming off of essentially, right, the sacrum, right, and it's also coming off of the ilium, much deeper. It's underneath the longissimus and the iliocostalis. And what do you notice about the fibers? Which way are they going? Medial. So only iliocostalis and longissimus move in the lateral direction. All the rest of these that we're dealing with, they're going to be moving in that medial, whoa, that was not what I wanted. They're going to be moving in that medial direction, like this. Okay? Because where are they inserting? Where are they inserting? And can you get more medial or median than spinous processes?
No.
No, you don't get any more to the middle than the spinous processes. So they have to come from lateral and go to medial if they're inserting on spinous processes. There's another muscle that you should understand belongs to this intermediate layer, right? And it's actually like two kinds of muscles, as we're dealing with semispinalis and we're dealing with some spinalis. This is one of the worst areas to have to do musculature, is the epaxial region, because the muscles actually do this. They interdigitate and they actually kind of pass through and leapfrog through each other. This is a nightmare to actually work on and dissect, so I am grossly oversimplifying it, okay? So instead of having to make you worry about all the differences, I'm just going to tell you as a basic, you're just going to have to worry about semispinalis. And what they're doing is they're essentially leapfrogging two joints and then moving up and coming off of transverse processes, crossing two joints, and then going to the spinous processes. That's pretty much it. Now, if we're talking about those muscles, you can start to see some of that right here. So again, notice what we're seeing is they're coming from the transverse and moving to the spinous processes. And you'll have some longer fibers which can go up to the head, right? But all of that basically belongs to the semispinalis. We're not seeing multifidus because it's deep. Multifidus is actually down here. Okay? It's not on this illustration because iliocostalis and longissimus are still in the way. But know that they're there. That's part of that intermediate layer. Now the deepest layer, these tiny, tiny, tiny things, they're actually several different kinds of muscles, long rotators, short rotators, things like that. don't make a big deal out of it. Essentially, here's all I really just care about is the fact that these are, rotators. That's it. There's basically just rotators. And these ones, again, are going to cross maybe two joints, and the short rotators are really only going to cross one joint, right? So when we look at these rotator muscles, here's where you're going to see them, right? Now, I do have a question for you, right? Where should you find these muscles? These are epaxial, and they're causing rotation of what? Are they rotating your arms and your legs? Or they're vertebrae. So where should you see them? Cervical and thoracic. So look at right there. Oh, that's too small. Rotator, 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 and then rotator, rotator, rotator. Right? Those are all rotators. You don't actually see them down there. Because that's not where you're doing rotation. That's where you're going to be doing flexion and extension. So all that kind of bony stuff is definitely tied to the muscles because those muscles are causing those movements that the bones and the bony articulations are going to allow. Now, for hypaxial muscles, see that's it, that's epaxial. Superficial, middle, and deep layers, and then the superficial layer, the erector spinae, has 3 blocks of muscle belonging to it, okay? Or 3 groups of muscle belonging to it, right? Hypaxial, right, is a little bit more complicated, and this is not even including the appendicular muscle, right? This is hypaxial without even talking about appendicular stuff yet. So, essentially, right, again, there is actually a kind of grouping of 3 things. So we see the 3 basic groupings of your hypaxial are body wall, right? I'm actually touching my pectoral muscles, so that doesn't count. Body wall down here, right? Then you have what you can't actually see unless you open somebody up, what's called prevertebral musculature, and that prevertebral is right in front of or anterior to the transverse processes, and down here in that lumbar region, right? And then the last thing is we have the limbs. So those are your basic divisions, right? Groups of your hypaxial musculature. Now, when we divide up the body wall group, there's a problem here because it looks like there's 4 things, right? 4 categories inside of the body wall grouping. However, right, there's actually a natural grouping of 3. Okay, so I'm going to show you what the grouping is, and you can tell me, maybe, that's the natural grouping of 3 right there. And I'm going to kind of change this just slightly. Essentially, when we talk about perineal, we're talking about this. That's basically what we're talking about. Perineal musculature is the stuff that's underneath your pelvis and holding your guts and all that kind of stuff in from the bottom. Okay? So, what do you notice about those 3? How are they related? And this is the odd man out. This is the weird one. What? There's something that's common to all of them. And that can't be common. I mean, they're connected to each other, right? But the neck is connected to the thorax too, right? So, I'm going to give you a hint. That's your hint. Why? Why is that your hint?
Is it the presence of a coelom?
There you go. Presence of a coelom. There's a coelom or body cavity for your abdomen. There is a body cavity extending into your pelvis. There's a body cavity, actually there's more than one. There are body cavities in your thorax. There is no body cavity in your neck. The lumen of your trachea, the lumen of your esophagus, that's not a body cavity. There is 0 body cavity in your neck. So that's the natural grouping of 3. And then the neck is the odd man out. Okay? Now, when we're dealing with the abdominal, it's best to start with these because they're the easiest ones to kind of understand. And they cover kind of a broad area. So what we're going to see with this abdominal musculature is 3 layers. Superficial, middle, and deep. 3 layers. So if we're dealing with the superficial layer, we're talking about the external, talking about the external obliques, right? You can just say external oblique, or if you want, you can say external abdominal oblique. And the fiber direction, okay, the fiber direction for these ones, we always say, and you should have heard this in lab, it's like you're putting your hands into your pockets, okay? So if you're kind of putting your hands into your pockets, your fingers will move in this direction, okay? Now, what's the purpose of having this body wall musculature? Why do you have this body wall musculature? All sorts of different functions, okay? What are some of the functions? What? Sure, right? You're actually movement, right? Movement, support, what else?
Protection.
Protection, right? And what else? So if you went to the bathroom and you sat there, can you use your abdominal muscles to help a little? No? You're sitting there and you're like, what are you using? You're using your abdominal muscles to do what? Pressurize your coelom, okay? So these are all the different kinds of things you can do. Now, the protection and the pressurization thing, those are related to each other, okay? But if we focus on the protective part of it, okay? So this goes back to people who actually fight, right? Either for fun or for a living, okay? You have to build up these muscles for protection, okay? Now, does anybody work with wood? Anybody do any, like construction or, right? No? Anyone ever seen plywood? In your life, have you ever seen plywood? Okay, now, why is it called plywood? Because there are different plies of wood. Now, what do you notice about those different plies of wood? The grain, the fibers are in different directions. Why? Because, yeah, it's stronger that way. Because if I have fibers that are going in this direction, right? Oh, wait, actually here, I'm going to give you a demonstration. I'm going to give you an explanation, okay? So, let's say I had a rectangular board, just like this, right? And the fibers of this board were going like this. Like that. So see how they're actually perpendicular to the long axis of this board? You guys see that? Yeah? So, would I want to use this board to construct something? Why not? Because it would break in half, right? Now, here's the explanation part of it. If I went to a martial arts demonstration and I wanted to show you how good I was at breaking boards, would I want to use this one? Yes. Exactly, and that's exactly what they do, is they use specially cut boards so that when you hit it like that, the board just goes like that. When was the last time you went to a martial arts demonstration, somebody hit that board and the board splintered and went like this, like that? When was the last time that happened? Never, because that's not the kind of board they use. They don't use real boards. They use specially cut ones. So what that means is these boards, these structures, are weak in between their fibers, right? So how do you fix that? You add fibers that go perpendicular like this. And then to make it even better, you can also have fibers that are going like this. So what you're doing is you're crossing the fibers, right, in a way that strengthens the weak direction of the other layers, which is why we have those three layers, superficial, middle, and deep layers. So for the external abdominal oblique, right, we have fibers going in one direction, so hands in your pockets like this. And then if you just stick your thumbs out like that, that's the direction of your internal abdominal obliques. External abdominal oblique, internal abdominal oblique, perpendicular. So the internal abdominal oblique goes like this, perpendicular. And then the last one, transversus abdominis. It's called that because the fibers are going in the transverse direction like that. Right? So essentially you get three layers where none of the three layers have their fibers lined up in the same direction. Gives you the most strength. Alright? So this is for your abdominal musculature, superficial, middle, and deep layers. Now, right, if we're talking about the superficial layer, the external abdominal oblique, okay, This is for a particular region, right? So one of the things that you want to pay attention to is, this is a repeating type of structure. So because it's repeating, one of the things that you're going to have to pay attention to, homologs. We're going to talk about homologs also, okay? So there's going to be a homolog for every single one of these layers, the superficial, the middle, and the deep layer. Now, with this, there's something else that you should pay attention to, is you also have something called a rectus sheath, okay? And we'll get to the idea of the rectus sheath in just a second, but what you'll notice is, what's happening is the muscle is actually inserting, so it's coming from here, and it's inserting onto the rectus sheath. Now, if we go to the next one, it says the same thing, inserting onto the rectus sheath. Yes, it's also inserting up onto some of those ribs right there, but it's ultimately going to insert onto what's called the rectus sheath. If we look at the deepest layer right here, transversus abdominis, where does it tell you that it's inserting? Onto the sheath, okay? Now, in order to understand this concept of the rectus sheath, we actually have to look at a different kind of orientation, right? So, one thing you have to see, right, is definitely there's going to be a superficial layer, right? So, this is the superficial layer, the external oblique. This is the middle layer, the internal oblique. And then this is the deepest layer right here, the transversus abdominis. So they're stacked like that. 1, 2, 3. Superficial, middle, and deep layers. Right? So that's one thing to understand. Now, in addition to that, what you want to see is you want to see a different kind of thing. Oh, did I not put it in the right place? Hold on a second. Are you serious? Oh, it's there. Ah, okay. I thought maybe I got rid of it for a second. Okay, I thought I accidentally deleted it. I didn't. Sorry, it just comes up later. It comes up when I'm talking about the rectus. I was kind of on a roll. Sorry, I messed up. Okay, so we'll come back to that idea. We'll come back to the rectus sheath in a second. But you have to know that it's there. You have to be aware of it. Now, the homolog idea, right? The homolog idea is whatever those layers that you have for your body wall, they're going to be repeating themselves in every other region where you have body wall. So where were the regions where we had body wall musculature? Hypaxial body wall. Abdominal, thoracic, and perineal, right? We still have it in the neck, but we don't have all the layers, okay? So for the thoracic region, all you're going to do is you're going to say, well, this is the superficial, this is the middle, and this is the deep. That's it. Or you can say external, middle, and internal, right? But those are your layers right there. Those are the layers that we're dealing with. So essentially, it's the same thing. The superficial layer is the most external. What's different, right, is the location of the muscle. That's it. The fibers are running the exact same direction. So external intercostals are between your ribs, but the fibers are still going the same way. Internal, fibers are still going the same way. It's the transversus thoracis that's the weird one. The fibers don't necessarily just go straight across, right? They actually kind of radiate out in all directions. It's a little bit weird, right? But you don't usually see that muscle anyway, so it's not something that I need you to identify, but you have to know that that's the homolog of the transversus abdominis. Okay, so when we're looking, right, this is the thing, is we're going to have a sternum right here, so this is sternum. And then back here, this is, vertebra back there. So what you're seeing is, as we're coming around, it's like somebody who's facing you. This is the right side of somebody who's facing you. Look at the fiber direction of your external abdominal obliques. Same fiber direction as the external abdominal, right? I'm sorry, did I say external obliques? External intercostals. Same fiber direction as your external obliques. And then your internals are perpendicular to that, which is the same fiber direction as your internal obliques, okay? Because they're homologs, so they're going to be doing the exact same thing. Now, for the perineal part, this is underneath your pelvis. This is under your pelvis, holding your guts kind of up inside of you, right? We still have a superficial layer, right? So same thing of the external, right? So it's the homologue, this is what we're seeing here, the homologue of the external abdominal obliques, homologue of the external intercostals. Now, this one is not just one thing, it's not just one muscle, it's actually, as a group, referred to as the urogenital diaphragm. It's called the urogenital diaphragm because it's related to your urinary and reproductive structures, okay? The way it's related to your urinary and reproductive structures is you actually have sphincters right here. Now, the only one that's actually listed right here is external anal sphincter, but there's also an external urethral sphincter for your urinary tract, okay? So that's related to this. But the one that you can clearly see and identify in a dissection is the external anal sphincter, okay? So that's why this is the urogenital diaphragm. It's that barrier, holding the guts in and separating it from the outside world. Now, there's another thing, it's called the deep transverse perineal muscle. That's the second part of it, okay? So I'll show that to you in just a little bit. For the middle or intermediate group, we have a different diaphragm. This diaphragm is called the pelvic diaphragm. And the pelvic diaphragm is actually made up of, again, two very, very basic muscles. I do not need you to separate out the levator ani into its component parts. All you need to know is that pelvic diaphragm consists of coccygeus and levator ani. Don't worry about the different parts for the levator ani, okay? And this actually does exactly what it tells you it's doing. It raises your anus, okay? So when you're on the toilet and you're pooping and you're pushing stuff out, right? It's not like you just have like this magical doorway that opens and then feces just falls out on its own, okay? One of the things that's actually happening is it's actually kind of the reverse of when you swallow. When you swallow, your throat comes up and it grabs the food and then goes down like this. When you're taking a dump, your anus opens and then it rises up and then the feces is able to get pushed out like that. So this is an essential part of, right, your kind of defecation. It's the fact that you're lifting your anus up like that. Now, we also have a deep layer. Now, this is also going to be sort of weird. So same way that the transversus thoracis is sort of the odd man out. It doesn't fit perfectly because it's not perfectly transverse. This is also weird. There used to be a little bit more muscle there, but when you grow and you kind of, develop, the muscle actually just kind of atrophies. It fades away, goes away, and all you're left with is fascia, okay? So it's not real muscle fiber anymore. It's just this connection of connective tissue, just overlying the musculature and forming that deepest layer. So even though it's not muscle, originally there was muscle there, so it's still the homologue of the deepest layer of your abdomen, the deepest layer of your thorax, right? So here is where you can actually start to see some of that. So what we can see right here, external anal sphincter. That's external anal sphincter right there. You can actually see the fibers coming down. So I'm showing it to you, and now I'm going to get rid of that so you can see the fibers. So you can see the fibers coming down, forming a circle of muscle around the anus. And that's all the sphincter is a circular muscle, okay? Now you can also tell that this is a female because there is an external urethral sphincter right there, and then there also happens to be another opening for the reproductive tract right there, okay? Now, this is why it's called urogenital diaphragm, okay? Now, those other sphincters, they're related to this muscle which we see kind of running across right here. This is the deep transverse perineal muscle. That's it right there, running across. So when you take all of that stuff together, that's what gives you your superficial layer, also called the urogenital diaphragm. If we're dealing with the pelvic diaphragm, then you're going to see some fibers coming down here, and they're going to go to the anus, because these are the fibers that are going to end up elevating and raising the anus up. So those fibers right there belong to levator ani. Pretty extensive. That's all levator ani that you're seeing right there. And that, in case you can't tell, is a little bit deeper in. Deep compared to the urogenital diaphragm. And then the other muscle that belongs to the pelvic diaphragm, right here, coccygeus. So you can see some of coccygeus right there, some of coccygeus right there. So those are the parts that make up your pelvic diaphragm. Now, If we were to look from the inside, then we'll look a little bit different, because we don't have that deepest layer of muscle anymore. No more deep layer. Transversalis becomes just fascia. So instead, what we're going to have is, you'll have coccygeus, and in case you can't tell, right, here's the sacrum, right there. This is all part of the sacrum right there. And then, there's a little bit of coccyx coming down like that. So, what we're going to have is some coccygeus coming down to insert onto that. And then you're also going to have levator ani, again, coming down. So here's levator ani coming down here in order to lift up the anus, which would be located right there. Okay? So these are the parts of your pelvic diaphragm. And then we're not actually seeing, right, any transversalis muscle, because there's no muscle anymore. It's just fascia. Now, that takes care of the three with the body cavity inside. For the neck, it never really had a proper body cavity, right? Even when you were an embryo, you didn't really develop a proper body cavity. So don't worry about that part of it. What is interesting, though, right, is there is some hypaxial neck musculature that was originally body wall that was actually torn out of your cervical region, and it then becomes body wall in a different area of your body. Okay? So this is your diaphragm. The diaphragm was originally cervical hypaxial musculature. Now, the reason for this is because, and this is going to come up in 224, your heart starts right here. This is where your heart begins. It begins outside of your head, up here. This is where the heart starts. Now, as you are an embryo and you start curling like this, the heart gets pushed down in front of your head, and it gets pushed down like this. As the heart comes down through your cervical region, it grabs the diaphragm musculature, pushes it down in front of it, and now what you end up with is, here's your diaphragm, here's your heart. And that's the arrangement that you should see in a normal human being, normal mammal. Is diaphragm here, heart on top of it. But the diaphragm originally came from your neck, okay? Now, here's the interesting thing, and we're going to talk about this for the limbs too, is the innervation that goes to your muscles actually happens pretty early on. Now, instead of when muscles are moving around and they're migrating and going to different places, instead of forming new nervous connections, that doesn't make any sense. What actually happens is once you make that connection to that muscle, wherever that muscle goes, the nerves are going to stay attached. Doesn't matter where they originally came from. Okay? So essentially, right, nerves and like their connections to muscles are like true love, right? You found your true love and you're never going to abandon them. That's basically what happens. Okay? So, where does the diaphragm start? In the neck, in the cervical region. But it's no longer there. Now it's here, forming a wall between your thorax and your thoracic body cavity and your abdomen, your abdominal body cavity. That's where it's located, but the innervation is coming from C3, C4, and C5. The innervation to the diaphragm actually comes all the way up here. This is where it originates from, C3, C4, and C5. And this is the explanation for if you have, right, basically like trauma, damage, or some sort of disease process, like a pathology, that is damaging the innervation coming down, right, let's say from your upper thoracic regions, right, all the way from like T1, right, you'll have problems with your limbs, but you can still breathe on your own because the innervation to the diaphragm is coming from C3, C4, C5. It's not coming from down here where your diaphragm is currently located. Okay? Now, the other thing, right? Scalenes. So there are these funny little strap-like muscles coming from your ribs and going up into your neck. That's basically all that's left of the cervical hypaxial musculature is the scalenes, right? So when we're looking, you'll really only see scalenes if you're actually doing like a dissection on these. Oh, are you going crazy again? So the scalenes, right, we're seeing is here's a rib, right? So this is the first rib right there, right? And you can actually see some of these muscles, and this is like a little bit right here, right? And it got kind of, like dissected away. So let me show you the other side. Here's the scalene coming up like this. And there's another scalene, posterior scalenes, coming up like that. That's it. That's what's left of your cervical hypaxial musculature. Essentially, basically just these scalenes. Okay? Now, strap muscles. They're called strap muscles because that's what they look like. They form like these long straps that are going up and down. Okay? So for the strap muscles, there is a whole series of them on the most ventral aspect of your body wall. That most ventral aspect of your body wall is on the midline. So they're essentially paired muscles, one on the right, one on the left, bracketing your midline, going straight up and down along the midline. So rectus abdominis is not one muscle. It's actually a pair of muscles, one on the left, one on the right. Okay? So for this, you're just going to name these. After we deal with the rectus abdominis, you're basically going to kind of name them for their origin and their insertion. Okay? This one is actually named for its appearance, right? Because rectus just means straight. This is the straight muscle of the abdomen, because it's going straight up and down. Okay? Now, the rectus sheath. So this is where I put this stuff, and I forgot that that's where I put it, right? Is when we're dealing with the rectus sheath, remember we had the external layer right there? So that's your external oblique, external oblique, external oblique. Okay? We're going to have a middle layer, internal oblique, internal oblique. And then the deepest layer, we're going to have the transversus abdominis right there. Transversus abdominis, transversus abdominis. Now, what you should notice, right, is I'm trying to highlight the muscle right now, but now what I'm going to do is I'm actually going to highlight the connective tissue. I'm going to draw on the connective tissue, which is essentially the tendon of these muscles. It's what they use to connect, okay? So it's going to connect to its insertion. Now, the insertion is actually here along the midline, and so really what they're connecting to is they're connecting to this structure that's right in the middle, right there, and it's called the linea alba. Right? So that's where your linea alba is. That's really what they're connecting to. Okay? Now, the way that they're going to do that is for the external abdominal oblique. Now again, I'm focusing on the tendon part of it now. The tendon of the external abdominal oblique comes across like this, just like that. And on this one, you can actually see it right there, and it comes across like that. And same thing right here, goes like that, comes across like that. Okay? I know it's going to get a little crowded and messy. Now, for the internal abdominal oblique, the section that we're seeing here is more superior. The section that we're seeing down here is more inferior. And what you should notice is right here, that is going to be your umbilicus, or your navel, your belly button. Okay? That weird white structure that you see right there for your linea alba. Now, what you should notice is the connective tissue for your internal abdominal oblique, if you pay close attention, you'll notice that it does this. Yes, it also goes there, and it splits, and it comes down this way too. Okay, right here, goes up and over superficially, and it splits, and it comes down there like that. Okay? Now, when you're dealing with the transversus abdominis, you're going to see transversus abdominis just goes underneath like this. Transversus abdominis just goes down there like this. Right? And then when we get inferior to the navel, below your umbilicus, this is where the change happens. There's a switch. And now, the connective tissue for your internal abdominal oblique goes like this. The connective tissue, the tendon for your transversus, goes like that. So now they're all external. Now they are all superficial to the rectus. But when we looked at the more like superior regions like there, Can you tell that the connective tissue is going around? It's actually wrapping around the rectus, more superficial and deep. Can you see that? It's forming essentially like a little tube like this, a protective tube that the rectus passes through. What do you call that? That protective covering? That's a sheath. That's the rectus sheath. It's made out of the tendons of insertion of your abdominal body wall musculature. Now, when you're up here, more superficial, it goes in splits and it goes superficial and it goes deep. But the further down you go, once you get past your umbilicus, now all of the fibers end up being on the superficial aspect. The reason why is because that gives you greater support when you're building up pressure and you're pressurizing things. So you essentially put all of the connective tissue on the outside to hold everything in. And you can develop a little bit better pressure when you do that. That's the reason for that. Okay? Now, what you'll see is, right, if you actually dissect away, you can see this stuff here. That's the rectus sheath, because when you first do a dissection and you skin somebody, right, or a cat, whatever, person, cat, whatever, right, a mammal, you don't actually get a good view of the rectus abdominis muscles, the actual muscle belly. What you'll see is you'll see the rectus sheath, okay? Now, if you kind of start to dissect everything away, right, then the next thing you'll see is there's actually going to be some of the sheath material deep to the rectus abdominis as well, okay? Now, if this is the anterior view, if you were to actually take that body wall and you flipped it over. Oh, did I get rid of it? I got rid of it. Okay, I thought it was still in there. Hold on. No, I got rid of it. All right. So, what I'm trying to, like, the point I'm trying to make is, if you were to flip this inside out and you actually looked at the rectus musculature from the inside, there's going to be a sheath on the superficial part, and there's the other part of the sheath on the deep part, deep to the rectus abdominis. But what ends up happening is, once you get past the umbilicus, there's actually going to be like a funny little line right there on the inside, where all of a sudden the sheath stops on the inside, okay? And there's no more sheath on the inside because the entire sheath has migrated to be on the external surface of the rectus abdominis, okay? So the sheath is not complete. It's actually incomplete when you're on the inferior portion deep, okay? More strap muscles. This is the one I told you we're going to talk about. Geniohyoid, from your chin down to your hyoid. This is all just part of these series of strap muscles. If it's a series of repeating straps, are they related to each other? Yeah. They're all homologs. So rectus abdominis, homolog of it is the geniohyoid. Another homolog, omohyoid, which sounds weird, comes sort of from your shoulder and then goes up towards your hyoid. It's going to pull your hyoid muscle, hyoid bone down, right? And then sternohyoid, right? And you've got sternothyroid. Those two muscles going up to your hyoid and going up to your larynx, right? The thyroid cartilage of your larynx coming from your sternum. Again, just long strap muscles. And it's telling you origin to insertion, origin to insertion. And then all the way down here at the bottom, pyramidalis. That one is just named for its shape. It's like a little pyramid-shaped muscle, right? And it's related to your rectus abdominis. And then the last little thing for the axial stuff, prevertebral. So this is that final grouping, prevertebral musculature in front of your vertebra, right? But that's deep inside. You actually have to open up the body, get all those guts and the kidneys and stuff out of the way, and then you can see the prevertebral musculature, okay? Now, there's one muscle that's like not listed here, but it actually is something that is part of, right? It's actually part of the prevertebral stuff. I didn't put it on there. I'm going to write this in there, right? So that you kind of know that there's something more to it. There's actually a kind of a grouping of muscle. There are two muscles. Psoas, right? One of them is the psoas major. The other one is the psoas minor, okay? These are also prevertebral. The only reason why I bring this up, okay, the only reason why I bring this up is because, right, you guys have hopefully hopefully, at some point when you guys were working on, you know, the stuff in the lab, you actually saw this. That's the only reason why I bring it up, is because you might have seen the iliopsoas muscle, okay? The reason why I bring it up is iliopsoas is not one muscle. Iliopsoas is actually a combination of two different muscles. One of the muscles that contributes to the iliopsoas is the psoas major, okay? So technically, iliopsoas is not one muscle. It's actually two muscles that have then combined and they have a shared insertion. It's sort of weird, okay? But the psoas part of it is originally a prevertebral muscle, okay? Now, the really straightforward ones, prevertebral muscle, longus, so longus coli, longus capitis, okay? And then the last one, quadratus lumborum, okay? Now, these two up here, longus coli, longus capitis, they're called that because they're relatively long. What does capitis mean? It means head. So where do you think it's inserted? On the head. And what do you think it's moving? Wherever you have the insertion, that's where you see the movement. So what is it moving? Moving your head. So it's actually flexing like this, flexing your head like this, okay? What does coli mean? Two L's, not one L. It's not colon like E. coli. This is coli with two L's. What does that mean? If I put two L's, what is this? Where does that go? It goes on the neck, right? That's because the original word, right, for neck, colus, with two L's, that's what it's talking about. So longus coli, it goes into your neck. So what we're going to see is longus coli is right here. Wrong one. Right here, inserting onto the neck. And again, remember, these are paired, so from both sides coming up like this. And then longus capitis is just a little bit lateral, and it's going to go to the base of your skull, right there. And inserts onto the base of your skull. So again, it's going to kind of flex your head like this. Those are your longest muscles. They're long kind of muscles. And then the last one, quadratus lumborum. It's called quadratus because I know that there's like a little point right. Whoa. I know there's like a little bit of a point right there, right? But kind of ignoring that, it's essentially a quadrangular muscle like that. That's why it's called quadratus lumborum, and it's in the lumbar region. That's why it's quadratus lumborum. Okay. Now, that's your axial stuff, right? Some of these, like you probably didn't see longus coli, you probably didn't see longus capitis. I guarantee you really haven't seen quadratus lumborum, right? But you should have seen your rectus abdominis, you should have seen your external abdominal obliques, those kinds of things. So this should have been sort of a very fast review of things with some conceptual stuff added in, okay? Now, the next thing, we'll take a break, right?